Hi everyone, welcome back. So this video we're going to talk about part 3, the basic data structure, BDS in ADAM training course. Okay, so myself Ali Sheikh, I'm the consultant at Trial Optima Inc. Okay, let's continue with this video. So the training module specifically covers the ADAM IG version 1.1 section 3.3. So if you go IG 3.3, you will be having ADAM basic data structures, BDS variables. So by end of this module, so you will be understand the fundamental structure of the BDS and dataset and how to implement them in your clinical data analysis workflow. So the required reference materials: ADAMS model version 2.1, ADAM IG 1.1, and the CDISC ADAM terminology. Okay. So the table of contents. So here we'll be going to explain the BDS fundamentals. So what is the BDS ADAM dataset? And we'll go through the ADAM BDS. And also we will be looking into the variable categories, identifier, the treatment and the timing analysis, parameters and indicator variables, and also the implementation of the structure of the ADAM BDS. So this module will guide you through the comprehensive set of BDS variables, including the specialized categories like toxicity variables and range variables. So what is the basics data BDS ADAM dataset? So the key characteristics: a standardized structure for analysis dataset, the support efficacy and the safety analysis across a wide variety of therapeutic areas. Okay, so the basic dataset used for most of the analysis datasets. It is unique among the CDISC data structures. Okay, so this is flexible to facilitate analysis and provide traceability. So the purpose of this BDS is to design, facilitate statistical analysis and regulatory submission by organizing clinical data in a consistent and analysis ready format. So basic data structures. So this is a vertical structures, analysis parameters are stored as values in a rows rather than as a separate variables in columns. So analysis ready. So the contains derived variables needed for analysis without requiring additional programming. So these three will be the series data structures in the BDS. Okay, so the traceability, vertical structure, analysis ready. So this is a core data structure for the BDS. So this is derived from finding events, interventions, and special purpose SDTM domains. Other ADAM dataset, any combination, thereof. So a record in analysis dataset can be represent and observed, derived, imputed value required for analysis. So here you can see the patient medical data. This is just a general, the vital signs data representation of for the BDS data structure. So the basic data structures, what is the BDS data set generally contains one or more record per subject. This is per subject, unique subject ID, per analysis parameter by param, per analysis visit, a visit, or per analysis time point. So this is a generalized data structure for the BDS. So for each subject will be having multiple records. So per analysis parameter, by param wise, per analysis visit, and per analysis time point wise for the vital signs. So in this example, you can see how multiple records exist for each subject with the different parameters and visit, creating the vertical structure that characterize the BDS data structures. So you may be here, there is one subjects are present. So it has multiple records. You see the multiple based on the visit wise and based on the time point wise and based on the param. Okay, this is BP. So this this is a simple example of the basic data structure. Okay, so if we continue for the next slide. So the BDS is a standardized analysis, facilitates standardized statistical analysis including ANCOVA, logistic regression and survival analysis. So it regulatory compliance aligns with FDA and other regulatory expectations for submission data, and it has adaptable frameworks. So it can be utilized, customized for specific therapeutic areas while maintaining the core structure. Okay. So the origin of this BDS data is developed by the CDISC to standardize analysis data sets for clinical trials. and it refined through multiple version based on the industry feedback and regulatory. So it has reevaluate the structures by using the multiple version, like by creating the multiple versions. The basically we have received they have received like feedbacks from the companies, different companies, and the regulatories departments. So it has keep updating them. And the current status, ADAM IG 1.1 established BDS as a core component for regulatory submissions. So this is the current status. And then the future directions continue to refinement to support advanced analytics in specialized therapeutic areas. So BDS serves as a bridge between collected clinical data and statistical analysis, streamlining the path for raw data to reportable results. Okay. So the core principles of the BDS, so this has one record per subject per parameter per time point, and analysis ready with no further derivation needed. So clear traceability to source data. So consistent structure across the studies. So there are some examples here. So we'll be having lab results, vital signs and efficacy, the primary and the secondary endpoints, and the safety, AE and the ECGs. So the common idea BDS data variables are identifier variables, the study ID, unique subject ID, and the treatment variables, the treatment related informations, and the timing variables, analysis visit, numeric format, and the time point. And we'll be having the parameters variables, param CD, the code part of parameters, and aval, the numeric value of the original results, and the indicator variables, the baseline flag and all 01 flags. So the x-axis represent the number of that particular record. Okay, so the next section will explore these variables category in detail, explaining their purpose and implementations requirement. Okay, so the first one will be the BDS identifier variables. So these core variables establish subject identification and ensure record uniqueness within the datasets. So here we have required variables, the study ID and unique subject ID. These are coming from SDTMs, and we'll be having the permissible variables, subject ID, site ID, and analysis sequence number ensures uniqueness. So these are identifiers. So a sequence is derived in a BDS not necessarily equal to XX sequence. So as derived rows may be added or sort order change. Okay. So if you go to the next slide. Oops, sorry. So the BDS identify variables example. So identify variable highlighted in example above, a sequence provide traceability for derived records. These variables from the foundation of any BDS datasets. Okay, so I think it's I need to change. Okay, so I have adjusted the image, so you can able to see here the study ID, unique subject ID, and the subject ID, site ID. So the A sequence. So these are the basic identifiers for the variables as an example. So A sequence provides the traceability for the derived records, and these variables form the foundation for any BDC dataset. Sorry. So the A sequence is critical for maintaining an audit trail from source to analysis data. So especially when multiple records exist in the same parameters on time points. So basically each record will have like if it's 001 will give for this subject, for this record will be having first record will be 1, and the second for the second record third. So it gives like up to, so if the subject was changed, it has given the again start with 1 as a new record for the subject 2. Okay, so this is just to give like the critical for basically meaning for audit trail to check the source of the analysis data. Okay, so continue with this one. So BDS record is level treatment variables. So these variables capture treatment information specific to individual records rather than subjects. So here we'll be having two different treatments, the planned treatment and actual treatment. So here we'll be having TRTP, which is a conditional variable, and the numeric version of the TRTP, and the planned pool treatment, so TRTP group, and the numeric version of the planned pool treatment. So here instead of plan, we'll be having the actual treatment, so actual treatment in the numeric version, and actual pool treatment. So at least one treatment variable is required in the BDS datasets. This can be any subject level, the TRT 01P or TRT 01A if it is a period 1, or record level, TRTP. TRTP is like final, like the duration of the treatments. Okay, so these variables will also be present in the BDS data sets. So the BDS data levels treatment variables examples. So the crossover designs, the subject received treatment C in a period 1 and subject received treatment D in a period 2. The TRT01P and TRT02 are subject level variables from ADSL. This is crossover for ADLB, record level treatment. So the TRTP, TRTA show the planned and actual treatment the subject was assigned at the specific time of each lab assessments. So this enables analysis by treatment at the parameter level rather than the subject, just a subject level. Okay. So the BDS record level those variables. So here we'll be having the two planned dose variables, those planned treatment doses for the particular record, and the cumulative planned doses at the time of the record. So it is a similar for the actual dose as well. So those, okay, so the subject level those variables you see here, those P and those A comes from ADSL and represent basically to doses the subject was assigned in the period 01 or 02. However, the record level dose, so if you have a record level dose, so the record level dose attached to the individual records in the BDS dataset are represent what dose was assigned when the assessment was done. So these record levels, those variables, would add a value to the study where subject can receive multiple different dose levels throughout the study. Okay, so in the units for those, so unit for dosing variables, multiple dose variables can be created with the suffix dose unit planned and those unit dosing variables units in the actual one. Okay, so the BDS timing variables, so here the point in time analysis time variables, the ADT, analysis date, time associated with the data point, and the time associated with the data point, so ATM. So ADTM is the date and time associated with the data point and relative day of the ADT, day since reference day. Okay, so this is study day, and there are flags for the date and as well as for the time point. So the BDS timing, the variables for capturing start or end times and intervals. The start time variables, analysis start date, analysis start time, and analysis start date and time, analysis relative date of analysis start date, and the imputation flags. And when come to the end time variables, the nomenclature is changed, like instead of S it will be having E here, end date, end time, end date and time, and the relative date of analysis end date and the imputation flags. Start and end variables are particularly useful when data points are collected over an interval of time rather than at a single time point. Okay, so the variables for the study design time points and organizations. So analysis visit, visit descriptions, analysis numeric version of the analysis visit, an analysis time point description, an analysis time point in the numeric format, and the reference point for the ATPT. And they are related to the phase as well and the period. A phase, analysis phase, analysis period, AS per A, analysis sub period, and relative time and units. So analysis visit being populated does not imply that the record is to be analyzed. Analysis flag should be used identify the analysis records. Okay. Okay, so the BDS timing variables examples of the date or time components. Example shows ADT, ATM, ADTM variables capturing assessment data time and the relative date. AD was derived based on the ADT and relative to TRT SDT. So visit and time points. Okay, analysis visit visit description, while ATPT breaks records down further into specific time point within the visit. Okay, hierarchical time structure enables flexible analysis at various temporal levels. Okay, so the next we'll be talking about the timing variables, the period, sub period, and phase. So the start date for the analysis period, this is the status for permissible and derive in a BDS format. So start time for the analysis period, so basically this is regarding to the period related to the time point. So these are the permissible variable, and origin is derived in the BDS. So start date and time associated for the analysis period. So a per SDTM, that is a permissible variable, and a per SDTF, a per STMF is a level of imputation for date or time conditional required if imputated. So you can check the module 11 for further details on the timing variable. So here we have okay, so let's continue with this part. So analysis window range. So the range of values for the time point and the 5 to 9 days. So for example, analysis visit windowing concept is very important in ADAM when you come to the ADAM imputations. So analysis visit window target. So the target day are relative times for the visit, and analysis window time difference. So the difference between the relative day analysis day and the relative time to target, and an analysis window low, analysis window high. So the window beginning and end time point. Analysis window range is 5 to 9 days. Then analysis window range is 5, and analysis window high will be the 9 if it is, for example, 5 to 9 days. Okay, so the analysis window unit will be the for both for low and high analysis window. These variables are only used where the SAP specifies that visit windowing will be done for analysis. So if the SAP has mentioned that there will be the visit windowing concept present, so we'll be considering this concept for identifying that visits for the target days. Okay, so here we'll be having the windows, example of the analysis visit windowing. Okay, so in this ADQS example, okay, so I have adjusted this image, and here you can see in this subject, like week 12, the assessment of our analysis date will be the 09 June 2014 according to the study day 88. Okay, so this falls within the week 12 windows, and the studies 1 to analysis window range 1 to 126. The target day of this visit was 84, so as shown in the AW target. Okay, so this is the fails in the week 12 because it's not close nearby to the target days. So this is kind of concept we'll be having the visit windowing when you're doing the clinical trial project. If you check the SAP, there will be a there will be a concept called visit windowing, so you'll be having better understanding there. Okay, so next we'll be considering the param. We'll be going to talk about the param and param CD. So the param is the parameters. The param code will be the code of the parameter will be the param CD, and the numeric format of the parameter will be the paramen, and the type of the parameter it will be considered as a param type. So it is important to understand the difference between the param and the test from SDTM. Within the SDTM, the test variable works in conjunction with other variables to describe the result that is collected. Okay, so here these are all permissible variables. Okay, so these are all permissible derived in PDS. So the parcat variable is used in the group of the parameters into categories. It should not be a qualifier for the parameters and should not be subdivide the data within the given para. Okay. Okay, so the analysis variable will be aval. So the both aval and avasi can be populated when may be useful. So here, so the numeric result value is described the param, so can originated from the original result, standard original result. So here in aval, the character analysis value is described by the params. So either aval or avas must be present in the dataset. For most parameters, only one will be populated. Both can be populated when useful, but must have one-to-one mapping. So the presence of both standardized result in character format and the numeric format, SDTM does not require both aval and avasi in the BDS. So the avalcat variable categorize aval C within the parameters, with aval C providing the numeric version, aval C in the grouping format. Okay. So example of the analysis parameter variables, the ADVS example above demonstrate. So here the example, the ADVS example above demonstrate the param has one-to-one mapping with both the param and paramen and param CD. So the param type indicates the BMI parameters is derived. You see here the BMI parameters derived, and avalcat1 shows the pulse rate result and the pulse result are abnormally low based on the SCP and metadata criteria. And just to be noted that param type was withdrawn in the new version of the ADAM implementation guideline. So here we'll be having the analysis parameter variables. So this is a specification and the metadata connections, the parameter derivations references CVLM. Okay, the CVLM for the one-to-one mapping with the param CD and params, and all CA1N derivation for C code list using the code list ADVS of so what does that mean? So here is this is the metadata. So when you click on this link VLM, it will go to the VLM, and you will be seen that how we have to derive the param in the numeric format and aval in the numeric format. So this is the metadata. So the notice the parcat was not used as it was not necessary to categorize these specific parameters. So this is the code list tab. In the code list tab, how the param in the numeric format will be derived here. In the VLM tab, I'm sorry, avalcat, and the VLM tab will be showing how the param related information to derive for the BDS data structure. Okay. And the next one is the analysis baseline flag and analysis baseline flag in the numeric format. So flag to identify the baseline record within the subject parameters and the baseline type, and this is a permissible variable, and also for numeric format will be the permissible variable. So the next we will be continue with doing talking about the baseline variables. The baseline variables are critical for measuring the changes in clinical outcomes. In ADAM BDS, several key variables support baseline analysis. The numeric baseline value for aval where ABLF fell equal to Y. So this is the numeric analysis baseline value for that subject and parameters, and the baseline type will be, if applicable, containing the value of aval from the record with ABLF equal to Y. So required if dataset supports analysis for the numeric baseline or functions functions of the baseline, and this is the conditional required and derived in the BDS. So the character baseline value from the aval C where ABLFL equal to Y, and the base type identify which baseline definition applies. So the definition of the baseline that is relevant to the base value of the record. If there is a multiple baseline definitions, multiple definition is exist, and this is the permissible variable. Okay, I'm sorry, this is the conditional variable, and we'll be having the change variable, the change from baseline aval minus base, and this is a small arithmetic calculations, aval minus base, and percentage change aval minus base by slash base into 100, that is the percentage we are multiplying with 100, so that gives the percentage of the change, and may require the categorizations require the change category and the percentage change category. Similar to aval C, the variable base C change and percentage may require their own categorization variable, the base cat and base cat in the grouping and the numeric format, and the change cat and the change cat grouping in the numeric format, and also the similar with the percentage change. So the analysis baseline flag equal to Y identify the records qualifying the as baseline, the last record on or before TRT SDT. Okay. So here we'll be having for example, if you have a like for example for this subject, you can see the okay, only one subject is, and there is a different parameters. So you have a systolic blood pressure and the diastolic blood pressure, and for the analysis baseline flag, because you're not considering the screening after giving the treatment administration, the screening you won't give any treatment, right? So after the screening, that record will be considered as the analysis baseline flag. So the prior administration of the drug. So this is the drug. This is the record where the parameters, like the vital signs has been collected. So that has the value there, and that is the baseline flag for each individual parameter. You see the diastolic will be having the second Y, and base values are retained across the parameter containing the aval where ABLF equal to Y. So if this 130 here for this particular record, and it will be continued for the remaining records for the base, and the change is calculated by aval minus base aval. So this is the original value of that numeric format of that standard result, and aval minus 163 minus 130 will give you change. Okay, the change. uh, so the change will be there. And next, the change category flags abnormal changes. If they have any abnormal changes, it gives like abnormally high. So this is the value is more high than it give the record the value as abnormally high. So percentage cat identify the percentage changes outside the normal ranges. Example, row 17, you can see that row 17 is abnormally low. That is percentage change cat. Okay. And the specification demonstrates how to implement the BDS. Okay, so the specification demonstrates how to implement the BDS structure for the vital signs data, including the source data, mapping from the SDTM of VS variables to appropriate ADAM variables. So the baseline flags implement of ABLF using the specific timing criteria. So the baseline flag is there, and the derived variables, the computation logic for base change, percentage change, and the category variables, the percentage change and patch, the category and percentage change category. Okay, so these are clinical relevant categorization variables. So the multiple baseline types real world applications. So the multiple study for the example shows two distinct baseline records, double blind and open label phase. So you see the base type, you have DB there and OL. So the two multiple baseline for one subject, because this subject went through two different from the blinded to the open label. So the period 2 starts on 12 Jan 2015. So period 2 is 12 Jan 2015, where pre-dose assessment for period 1 also serve as the baseline for the period 2. Okay. Okay, so the basically it is saying that the periods 2 start date for this is baseline double blind. The start date for that one the same, and it will be the same with the open label phase. Okay, so the base type implementation, the base type variable DB or OL differentiate which baseline definitions applies to each record. So these are differentiate like which baseline has open label and the double blind, and the phase specific analysis baseline flag are per base type, where with the base change derived using the corresponding baseline for analysis. Okay, so you can see the change and the base will be the difference for based on the analysis baseline flag differences. Okay, so the next one will be additional analysis parameter variables. So we'll be having the ratio to baseline aval minus base aval I'm sorry high slash base, and the ratio to lower limit and ratio to upper limits. All ratio variables are permissible, not required in BDS data structure. And the shift variables, the test description of the shift normal to high, and the numeric version of the shift 1:1 mapping. So I can be based on shift between the base cat, aval cat, baseline range indicators, analysis range indicators, the baseline indicator, analysis range indicators, toxic grades, the base or aval. All this can be based on the shifts between them. Okay, so the purpose of the D types, so it indicates how a record has been derived, especially when imputation methods have been applied. So required analysis values have been imputed, derived differently than other values within the parameters. The common D-type values are last observation carry forward, worst observation carry forward, and average of the values. Okay, so these are some common types of imputations as per the SAP. So if an entire parameter is derived, not just individual records, use param type instead of D types. So as I mentioned, the param types has dropped in this new version, so the D type will be there.